Okay, so welcome back to this next video in which we're discussing clathrin-mediated endocytosis, where we're specifically looking at now the function of Dynamin 1 and endophilin. Okay, the function of Dynamin 1 and endophilin is basically to pinch off the clathrin-coated vesicle bud now and actually turn it into an endocytic vesicle. Okay, right, so we're now at the moment looking at the activation of Dynamin 1, and we've discussed how its function is dependent on calcium entry into the cell. So, when an action potential arrives in the axon terminal, this causes calcium entry through the N and PQ type voltage-gated calcium channels. Excuse me. And then what that calcium is going to do is it's going to bind to the apocalmodulin. 4 calcium ions are going to bind to the apocalmodulin, one in each of these calcium binding sites, and that's going to convert the apocalmodulin into a calcium-calmodulin complex. And now let's see what the calcium-calmodulin complex does. Okay, and we'll need another piece of paper for this. Right, okay. So, basically, the calcium-calmodulin complexes are going to bind and activate an enzyme known as calcineurin. Okay, so in the typical enzyme fashion, we will draw a box with a hole in it. So this is calcineurin here. Okay, and calcineurin is a phosphatase. It removes phosphate groups from proteins. Specifically, it's a serine-threonine phosphatase. Okay, so calcium-calmodulin complexes here are going to come and bind to our calcineurin enzyme, and they are going to activate it. So here comes our calcium-calmodulin complex with these 4 calcium ions bound to it. Okay, and when the calcium-calmodulin binds to the calcineurin enzyme, it's going to activate it. Now, before the calcineurin becomes activated, i.e. before the calcium signal arrives in the cell, in the cytoplasm, you have the protein Dynamin 1. Okay, so this is the protein Dynamin 1. Okay, here. And we'll have it in purple. Now, in the resting state, i.e. when you're not endocytosing the vesicles, when you're not pinching off the clathrin-coated vesicle pits, Dynamin 1 is in the cytoplasm and is doing nothing, and the reason it's doing nothing is that it has a phosphate group attached to it that is inhibiting it. So this is a phosphate group here. Okay, and I usually denote phosphate groups in pink, but I can't do that now because I've coloured the Dynamin 1 in pink. So we'll have to denote the phosphate group in red. That's a good compromise. So here is the phosphate group attached to the Dynamin 1 protein. Now, when the calcineurin protein becomes activated, what it's going to do is it's going to remove that phosphate group from the Dynamin 1. So it's going to come over here, chop this off. So I'll put an inhibit sign on the phosphate group. So it's going to remove that phosphate group from the Dynamin 1 protein. So this is Dynamin 1. Okay. And Dynamin 1 is now going to go and wrap around the neck of the clathrin-coated vesicle, basically. Or the clathrin-coated vesicle bud, or the clathrin-coated vesicle pit, as you'd call it. Okay, so let's go back to our membrane. So, here's our membrane. Here is our clathrin-coated vesicle bud or vesicle pit. Both of those terms are used. So here's the clathrin coating this vesicle bud or vesicle pit. Okay, and we now want to help the clathrin out. Oh, and I shouldn't do this in pink, otherwise things are going to get terribly confusing. We'll have this in blue. Turquoise, not blue. Okay, so in turquoise, this is the clathrin here. So this is the clathrin polymer, or the clathrin buckyball. Okay, so this is clathrin polymer. Okay, and the whole structure is referred to as the clathrin-coated vesicle bud. Yes, that's it. Clathrin-coated vesicle bud. Or you can also call it the clathrin-coated vesicle pit. Both of those terms are often used. pit, like, I don't know, pit, maybe, yes, there. Clathrin-coated vesicle pit. I wanted to put 2 T's for some reason, but no, I think that's the name pit, like the Prime Minister. Okay, right. So, what's now going to happen is once the Dynamin 1 has had its phosphate group removed, which has occurred because the calcium has gone up in the cytoplasm, Dynamin 1 is now going to oligomerize. So I'm suddenly going to shrink this hugely, and it's suddenly going to change shape as well. So it's going to suddenly take the shape of a little ball, basically. And basically what's going to happen is the Dynamin 1 is going to polymerize around the neck of this vesicle. So each of these little balls represents the Dynamin 1 protein. Okay, so let me show this again in a bigger picture. So, what's going to happen is that you're going to gradually oligomerize more and more Dynamin 1 on here. And what's going to happen is you're gradually going to force this neck to get longer and longer. So what's going to happen is as you build the polymer, this neck of the clathrin-coated vesicle bud is going to get longer and longer, like so. And what you're going to do is you're going to create these sort of what shall I call them? Spirals of clathrin around, of Dynamin around this neck. So, what's happening is it's spiraling around the neck. I'm only showing you it from one side, so you're only seeing it going along one side, but it will go back round the other side, and it will come round to here, and it will spiral around that neck of the clathrin-coated vesicle bud. Okay, so here's the clathrin still coating the vesicle bud here. Okay, and these are Dynamin 1 proteins all oligomerizing together to form this spiral around the neck of the clathrin-coated vesicle bud. Okay, now let's discuss the other function of Dynamin 1, because this isn't quite yet how it's going to cause the pinching off. Dynamin 1, okay, so Dynamin 1 is also a GTPase. So Dynamin 1 is a GTPase, which means that it hydrolyzes GTP to GDP and inorganic phosphate. So, let me remind you of the structure of GTP. So the structure of GTP then, guanosine triphosphate. It consists of guanosine with 3 phosphate groups bound to it. So what is guanosine? Guanosine is the name for the organic base guanine. So here is the organic base guanine, okay, bound to a ribose sugar. So we'll colour in the guanine organic base in turquoise here, okay, and then we'll colour in the ribose sugar here in red. Okay, and remember ribose is the sugar phosphate backbone for RNA, not DNA. So this is the ribose sugar. Now, when you have ribose bound to guanine, this is guanosine. Okay, so what is meant by guanosine is guanine bound to ribose. Okay, and guanosine is what's known as a nucleoside. So not a nucleotide. We'll discuss what a nucleotide is in a moment. A nucleoside. Now, a nucleoside is basically the organic base, the DNA organic base, or the RNA organic base, the nucleic organic base, okay, with a ribose sugar bound to it. That's what a nucleoside is. So what's a nucleotide? A nucleotide is an organic base with a ribose sugar with phosphate groups bound to the ribose sugar. So guanosine triphosphate, which is guanosine with 3 phosphate groups bound to it, would be a nucleotide. Okay, so it would be an example of a nucleotide because it has the phosphate groups. So now let's add some of these phosphate groups on. So guanosine triphosphate, basically you stick 3 phosphate groups up here. So let me colour these in purple. So these are the phosphate groups. Okay, and these phosphate groups are labelled. This first one that's attached to the 5th carbon of the ribose is labelled the alpha phosphate. This is labelled the beta phosphate, and then gamma. So just the first 3 Greek letters, alpha, beta, gamma. Okay, and that is a nucleotide, and this is guanosine triphosphate because it has 3 phosphate groups on, and for short, GTP, guanosine triphosphate. Now, basically what you can do is you can chop off that gamma phosphate to create GDP, guanosine diphosphate, and an inorganic phosphate. So you can chop it up into guanosine diphosphate and also a single phosphate group here, which will be the gamma phosphate coming off. So this is denoted PI for inorganic phosphate group. Right, and when you do that hydrolysis, which is cutting this bond here between the gamma phosphate and the beta phosphate, that's going to release a lot of energy. Okay, now this is how Dynamin is going to pinch off the neck of this clathrin-coated bud. Basically, when it oligomerizes like this, the GTPase activity of Dynamin 1 is going to go up. Okay, so its activity in breaking down GTP into GDP and inorganic phosphate is going to be turned on when it oligomerizes. So, it's going to start converting GTP to GDP and inorganic phosphate once it's formed this beautiful spiral here. And when it does that, what it's going to do is it's going to cause this spiral to tighten. Okay, so it's going to tighten around that neck. In addition, it's going to stretch out. So let me show you this conversion. Okay, so we're going to go from this to, it's going to stretch out, okay? And here's the pit down here, or the new vesicle. It's also going to thin up, basically, here. And this is the pinching off process, basically. Okay, so what's happened then? The Dynamin has hydrolyzed the GTP, and it's used the energy to tighten up on the neck of this clathrin-coated bud. So it's still a spiral is what I want to show you. So I'll colour these in pink here. It's still a spiral. It's still spiraling around that neck. It goes up and round and round and round. But it has tightened hugely on the neck. So where has all the length of this sort of rope gone? Well, it's gone into extending the neck, pulling it round. So it's basically as though you've just tightened up that string that was going around the neck. And it's pulling this connection between the clathrin-coated vesicle bud and the extracellular fluid. It's making it smaller and smaller and smaller. Okay, so here is the clathrin still coating this vesicle now. And this is the pinching off process, and this is how you're going to pinch that off. So eventually this membrane is going to pinch off and the vesicle will be separate from it. And that's the role of the protein Dynamin 1. So this is the pinching off process. Pinching off process. Okay, so that's the role of Dynamin 1 in this. Where does endophilin fit in? Well, we'll see that in the next video.